Hello everyone, my name is Pablo Andres Collazo Ortiz, and in this video I will explain the solution exercise number 1 from the text 4 of the Electromagnetism course. And this activity focuses on the calculation of magnetic flux stroke and motor with several laps or turns, and include the analysis of this behavior over time, the calculation of include the electromagnetic force and the resulting electric current. And the point A, and the point A, um, we are given magnetic field vector with written as B equals 15, B equals 15 and minus 3, G minus 3 key Teslas. Okay, and these minus components are the fighting the and the fighting in the x direction E minus 3 in this day y direction j, and minus 3 in the c direction k. Okay, we also on the r vector and point in the direction of key with the magnitude 132 points and the three several square meters. So the r vector is an equal 122 points and the 37 key. Yeah. Um, um, Since only on the set component of the magnetic field, the key component contributes the dot product with area we calculate. Phi equals B dot phi equals B dot. And I wish negative 3 times and the 100 feet at 2.37. That gives negative 367.11 Webers. Right? Correct. Okay, Webers. The angle between and the field and the area vector is 3 degrees calculated as 45 times alpha plus 10. Okay. Since alpha is 0, the angle is just 10 degrees. So we be cosine, applying cosine of 10 degrees, cosine the 10 degrees. So we apply the cosine the 2 degrees approximately 0.9848. Therefore, field equals 367.11, the 0 point, and the 948, which is having approximately 316 of the 5 Webers. Finally, since we have 12 loops, total magnetic flux equal 2 times 360, and the point which approximately 2,338 Webers. Okay, and point B, magnetic flux with the magnetic field varies in the time. We consider a time varying magnetic field expressed as B of t equals B now times cosine of omega t. Omega t is where omega is angle frequency. In the Earth case, frequency is 60 hertz. 60 hertz. Okay, and so angular frequency omega equals to p times 8. That gives omega equals 103 times p radians per second. The expressions for magnetic flux as function of the time becomes phi of t equals 12 times 20 times p radians per seconds. The expression, the expression for magnetic flux as function of time becomes phi of the equals 12 times on 120.3 7 negative 3 times constant on the 103 pt. This is simple too. Simplifies too. Phi of the equals negative for 2000 for 205.3 times cosine of a 120 pt in the Webers. Okay. Let's evaluate the flux and the three moments in time. And the t equals 0 second. Phi of 0 equals negative abstraction or 405.3 times cosine of 0, which equals negative 4,405.3 Webers. For t equals 0. And the t equals 10 seconds. Phi on the 10 equals negative, and equals negative 4,405.3 times cosine of the 200 p, and the cosine alpha multiple of 2p equals 1, so again negative 4,405.3 Webers. Okay, and the equals 6 seconds. 60 seconds. Cosine of 7, 2200 Pc also 1 on the flux remains the same negative 4,405.3 Webers. All right. To find when the flux equals the value on the Greek cosine of omega t equals 0.9848, which gives omega t equals p divided by 18, so t equals 1 divided by 120 times 20 times 18, approximately 0.00014 seconds. Okay, point C. Induced electromotive force MEFM. According to Faraday's law, epsilon of the equals negative derivate for P of t with respect to time. Phi of t is negative 4,405.3 times cosine of 120 pt. So the derivative is epsilon equals positive 4,405.3 times on the 103 pt p times sine on the 120 pt. Right? Epsilon that gives epsilon and the equals approximately and the 0.16 to the 6 multiplied by 10 and by 120 p 3 volts. Okay. And finally point B current and the time the equals 10 seconds. Now we apply Ohm's law. Current equals voltage divided by resistance. We are told the battery voltage is 9 volts. The resistance of the wire is the 100 ohms, and the induced EMF and the 10 second is 0 because sine of the 1200 equals 0. So current equals 9 volts divided by 100 ohms, which giving 0.08 amperes. That is 9 milliamperes. 9 milliamperes. Conclusion. And the summary, this exercise demonstrates how the magnetic flux behaves through a rotting coil on the undervolt constant and the time varying magnetic fields. We sum with it certain dives one frequency values, and the flux remains constant with the calculate the induced electromotive force using Faraday's law and finally determine the induced current in the motor circuit. Thank you for very much for your attention. See you again.